Hi everybody, it's Mr. Mott. I'm going to talk about an idea called molarity. Molarity is a way to express concentration using the idea about moles. And so our formula for molarity is moles of a substance per liter of solution. And so, since this is a three-variable equation, we can do our little triangle trick. Okay. Put capital M for molarity, N for moles, and L for liters. Okay. So this is a real key idea, and anytime that chemists want to make a certain solution, they need to use this idea about molarity. It's very, very common. All right. So let's say that we wanted to prepare 1,000 milliliters of a 2.5 molar NaOH solution. Okay, and we wanted to prepare that. So, first of all, since we had this idea about a molar solution, we're going to use this idea about molarity. So let's just take stock of what information we have. Okay, here's my molarity equation. So I know the molarity here, and I know the volume, or although I'm going to have to change that a little bit. So I know the volume there. So what can I do? I can solve for moles. So I'm going to rearrange my equation. Remember, our trick is to cover up what you're solving for. So I'm going to cover up N, and it's going to be M times L. So moles equals molarity times liters. My molarity is 2.5 molar. And 1,000 milliliters, my decimal point is here, okay, is equal to 1 liter. Okay? And so that's a conversion that we're going to need to know, maybe right over here. 1,000 milliliters is equal to 1 liter. So I'm going to write 1 liter here. So doing our math, 2.5 times 1, 2.5 moles of that's NaOH. Now, this is great because now a chemist knows how many moles of that chemical that they need. And so what they would then do now is take this number of moles and convert it into grams. So I'm going to take this 2.5 moles of NaOH, and we're going to solve for grams of NaOH. And so I'm going to put moles NaOH on the bottom, grams NaOH on top. And when we think grams per mole, we're thinking molar mass, so this is for every 1 mole. And the molar mass of NaOH is 40. Okay, so I got that because the molar mass of sodium is 23, oxygen is 16, hydrogen is 1. We add those up, and that should equal 40. So that's how we got our molar mass. And now solving, we're going to take 2.5 times 40, which should equal 100 grams. So what a chemist would do, they're going to weigh out 100 grams of NaOH. They're going to put it into what's called a volumetric flask. They're going to dissolve it and dilute all the way up till they have 1 liter of that solution. And then they'll know that they've made a 2.5 molar solution of NaOH. All right? In all these different problems that we're going to use, we're going to be using our molarity equation, so we want to be able to work back and forth here. Anytime you're dealing with the molarity problem, start out with your equation, take stock of what you have and what you can solve for, and recognize that a lot of these problems are going to be sort of multi-step or two-step problems. All right? Thanks for watching.